In this section, we are going to multiply and divide rational expressions. So first of all, we're going to talk about simplifying a rational expression. You want to factor the numerator and the denominator, divide out the factors common to both. So if we had like 15 over 65, they both will divide by 5. So 3 times 5 over 13 times 5, the 5 would cancel, and we'd have 3 over 13. If we have something like x plus 2 quantity squared over x squared minus 4, well, this is the same as x plus 2 times x plus 2 over, this is the difference of squares, which is x plus 2, x minus 2. So you end up with x plus 2 over x minus 2. And then we're going to do some multiplying. The multiplying rational expressions, that would be where we factor the numerator and denominator on both of them, and then simplify by dividing out. So if we have a problem that looks like this, we need to factor, these are not factorable at this point, so we will factor these parts and then we'll cancel what they have in common. And if we're dividing, the thing we have to remember with dividing is when you divide, we will flip the second fraction over because we don't divide by fractions, we multiply by reciprocals. So we'll flip that over to do that one. All right, so let's go look at an example. So I'm going to work, I just kind of talked about this example, but we're going to work it out on paper. So if we have something, like I said a few minutes ago, x plus 2 quantity squared over x2 minus 4, that x plus 2 quantity squared means it's x plus 2 times x plus 2. This is the difference of squares, which we've learned this whole semester on how to factor that. So that's going to be x minus 2, x plus 2, because we're basically taking the square root of both parts to put it in there. And one is minus, one is plus, and that's what gets rid of that middle term. Now we have x plus 2 over x plus 2, so we end up with x plus 2 over x minus 2. And that's all you have to do with that. All right, let's look at example 2. If we have 2x squared over 10x cubed minus 2x squared, what we want to do is factor out what we can. So here we have 2x squared, not going to factor at all, it's a monomial term. Down here they both have a 2 in common for the number, and they both have an x squared. So 10 divided by 2 will get me 5, and x cubed divided by x squared will leave me with an x to the 1. And then this whole 2x squared cancels out, or factors out, so we'll end up with a minus 1. Our 2's will cancel, our x squareds will cancel, we'll end up with 1 over 5x minus 1. All right, example 3. We have 9x squared plus 13x plus 4 over 8x squared plus x minus 7. Now this is where you need to know how to factor. If you don't remember how to factor, there's a video on AC method factoring. It's a good way to do it. I'm not going to do all of the factoring here because it would take us forever. And many of you already know how to do it. So we would factor this using the AC method. And we'll factor the bottom at 8x minus 7 times x plus 1. So here we would cancel those out, and we end up with 9x plus 4 over 8x minus 7. All right, let's look at example 4. If we have 2 plus x over x plus 2, this is being added in both cases, so I'm just going to change the order. This is x plus 2, same as 2 plus x, over x plus 2. Well, that will get us 1. Because they both canceled, but you end up with, when they cancel on both top and bottom, it ends up being a 1. All right, let's look at example 5. Here we have 2 minus x over x minus 2. Well, let's change the order again so the x's are in the front. So I have negative x plus 2. Up here, they were both positive. Here, the x is negative, so make sure you bring that negative sign with it, over x minus 2. Now what you might notice is that the difference between these two is that the signs are opposite. So I'm going to factor out the negative one on top and get x minus 2 over x minus 2. Oh, okay, so our x minus 2's will cancel and we're left with negative 1, which makes sense because the signs are the only thing that's a difference in there. All right, let's look at example 6. So we have x cubed plus 8 over x plus 2. Well, this is the sum of cubes. So recalling how we factor that, we've got to find that a and the b and then plug them in using our SOAP formula. So we end up with x plus 2 times x squared minus 2x plus 4 all over x plus 2. Well, the x plus 2's will cancel, and we have x squared minus 2x plus 4. And recall that when we do the sum and difference of cubes, this part does not factor with the AC method. All right, let's simplify another problem. This will be example 7. So we have 2y squared plus 2 over y cubed minus 5y squared plus y minus 5. Well, the top, we can factor out a 2. We get 2 times y squared plus 1. Now this has 4 terms. So with 4 terms, we can split them in 2's and factor them out. So this is factor by grouping. So we are going to, on the first part, we can factor out a y squared. And we end up with y minus 5. And on this side over here, bring down our plus side, we can only factor out a 1. And we get y minus 5. We know we're on the right track because in the parentheses we have y minus 5. So this will become y minus 5 times y squared plus 1. And y squared plus 1 is not going to factor because it's not the difference of squares, it is the sum of squares, and those are unfactorable. All right, so this will be y minus 5 times y squared plus 1. Well, our y squareds plus 1 will cancel, and we end up with 2 over y minus 5. All right, so we've done some simplifying of our radical expressions. Now we're going to look at multiplying. So we're going to multiply rational expressions. So this will be example 8. We have 1 plus 3n over 2n times 2n minus 4 over 3n squared minus 2n minus 1. So for this, we are not just going to multiply everything. We're going to see if we can reduce it first. So the first two terms, or the first term over here, the numerator and the denominator, they will not reduce. There's nothing to factor. But on this term, I can factor out a 2, and I get n minus 2. And on the bottom, this will factor out with the AC method, 3n plus 1. You could also use the box method that you can factor n minus 1. Now, we've already looked at some problems earlier where we saw that we had 2 plus x and x plus 2. When we figured out that's really the same thing because it's the addition property. So here we have 3n plus 1 and 1 plus 3n. So these two will cancel each other out. The other thing is we have a 2 times something over here and a 2 times something over here. So the 2's will cancel. And we will end up with n minus 2 on our numerator and n times n minus 1 in the denominator. And that would be your final answer for that one. Our next problem, we have x cubed minus 1 over x plus 3 times 15x squared over x squared plus x plus 1. All right, so here we have the difference of cubes. Using our formula, we end up with x minus 1 times x squared plus x plus 1 over, here we can factor out the negative 3 and get x minus 1 times, we have our 15x squared over, now notice that this is the same as that. This is not going to factor because, as we know, we discussed already, with the difference or the sum of cubes, this will not factor with the AC method or the box or anything. So, but they match. So we don't have to worry about even will that factor out because it's going to reduce with this. So the x squared plus x plus 1 will cancel with this one. The x minus 1s will cancel. And our negative 3 will reduce our 15 to negative 5. So our answer will end up being negative 5x squared. Or you could have just reduced it to 5 and left the negative sign, but if you can do that. And that's just it. That's your final answer right there, negative 5x squared. All right, so let's look at dividing our rational expressions. It's going to work the same way as the multiplication except for the first step. So our first problem we're looking at is 8m squared over 3m squared minus 12 divided by 40 over 2 minus m. The very first thing you have to do is change this to multiplication. Remember, we don't divide by fractions, we multiply by reciprocals. So this will be 8m squared over 3m squared minus 12 times 2 minus m over 40. So I leave the first fraction the same, but the second one becomes times the reciprocal of it. Now that we have this at multiplication, we can move forward and do what we did up in the previous problems. So our 8m squared is going to be the same. Our 3m squared minus 12, we can factor out a 3, and m squared minus 12 then becomes m squared minus 4 times our 2 minus m over 40. Well, m squared minus 4 is difference of squares, so we end up with 8m squared over 3 times m minus 2, m plus 2, times our 2 minus m over 40. Now, if you recall, previously we had our 2 minus x, which is the same thing as negative x plus 2 over x plus 2. And so the difference with that was a negative 1. And we're going to use that process here. Because we have 2 minus m, we know that that is the same thing as negative m plus 2. Here we have m minus 2 and 2 minus m. They're basically the opposite signs. So this will reduce with that, but it will leave us with a negative 1 for that part. Or you could, if you wanted to, you could factor out the negative 1 times like we did before. You can either recognize that, or you could look at this. If you factored out the negative 1, you get m minus 2. Whichever makes it easier for you, you're still going to end up with a negative 1. All right, 8 will go into 40 5 times. So let's see what we have left over here. So this will leave us with a negative 1 times our m squared over 3 times 5 times our m plus 2. So negative m squared over 15 times m plus 2. So that would be our final answer on that one. All right, so let's do another division. So this will be example 11. We have 18 y squared plus 9y minus 2 over 24y squared minus 10y plus 1 divided by 3y squared plus 17y plus 10 over 8y squared plus 18y minus 5. All right, like I said before, the first thing we have to do is flip that second fraction and turn it into multiplication. So 18y squared plus 9y minus 2 over 24y squared minus 10y plus 1 times 8y squared plus 18y minus 5 over 3y squared plus 17y plus 10. And if you notice when I do these, I do not factor them yet. I always just make sure I take care of turning the division into multiplication, because otherwise we end up forgetting that part and we end up with issues. So I just do that first, and then I can write the problem, and then move forward. All right, so now we're going to factor. The top one over here, the 18y squared plus 9y minus 2, will factor to be 6y minus 1 times 3y plus 2 over 6y minus 1 times 4y minus 1 times 4y minus 1 times 2y plus 5 over 3y plus 2 times y plus 5. So we factored all of our problems. So let's see what will cancel. We have 6y minus 1s that will cancel. We have a 3y plus 2 that cancels. We have a 4y minus 1 that cancels. So the only thing we have left is 2y plus 5 over y plus 5. And that would be our final answer. So a lot of these look tedious in that, but a lot of it goes away. It simplifies down as you're factoring them. But you've got to know how to factor. So if you don't know how, make sure you go back and look at the factoring videos.